Good morning, majors. So today we're going to look at Unit 5, Day 3 notes, and we're going to prove that these triangles are similar by side, angle, side. Okay, so we're going to look at two sides and the angle in between it. Remember, the two sides are not necessarily equal. They're just going to be proportionate, but the angles in between it do have to be equal. Okay, so if an angle of one triangle is congruent to an angle of the second triangle and the lengths of their sides adjacent these angles are proportional, then the two triangles are similar. Remember, we're trying to prove that they're similar. Then fill the similarity statement. Show that the given triangles are similar by side, angle, side. Then fill in the similarity statement. Well, I know that if they're similar, then this side over this side. Remember, we do left-hand triangle over right-hand triangle. So 1 over 2 has to be equal to left-hand triangle's biggest side over right-hand triangle's biggest side, which is 3 over 6. Plug that into your calculator. 1 over 2 gives you 0.5. Is that equal to 3 over 6? Plug that in your calculator. You're also going to get 0.5. So yes, the sides are equal. And the angles in between them are equal because they have this little congruency mark, right? That means that they are equal. So we're going to say angle J is congruent to angle X, right? Because they have those little congruency mark. So we have everything we need to prove that these two triangles are similar. So I need to write it in order. The first one, they didn't matter. They put J to K to L. The second order, it depends. The order matters, right? So J is the one with the congruency mark, which is going to be X. And then K is the red line, which is going to be Y. And then Z. I have two sides that are proportionate and the angle is touching both of the sides. So that's side, angle, side. Remember, we had a lot of SAS in congruent triangles. We can't forget that. Show that these two triangles are similar. So you can tell that they're not equal because this little one, baby one, is inside of the big one. But the big triangle, we need to calculate the actual side lengths of the big triangle. And what I wanted you guys to do in the last chapter is separate it. Separate them. So this baby triangle is going to be this one, and this is J, M, K. And this is 4 and 5, right? And the big triangle, we don't have to make it completely as big, but we do need to find out what the side lengths are. We're going to have to add them together. J, S, Q. Okay. So J to S is actually 4 plus 12, which is 16. And J to Q is actually 5 plus 15, which is 20. Okay, so we know that they're sharing a common angle. Their common angle is J, right? So of course, angle J is going to be congruent to angle J, and we saw this, and what our reason was the reflexive property, right? Anything can be congruent to itself. Now we need to know if the sides are proportionate. So I'm going to use a left-hand triangle over the right-hand triangle. So I'm going to say 4 over 16, is that equal to, question mark above it because we're not sure, 5 over 20, right? 5 over 20. Are they equal? Well, if you look at 4 over 16, if you plug that into your calculator, you're going to get 0.25 or 1/4 is equal to 5 over 20. You will also get 1/4 or 0.25. So yes, we've done everything. We know that my angles are congruent, and then the sides on either side of those angles are proportionate. So that's side, angle, side. So we're going to use side, angle, side. We don't have as many similarity reasons as we did congruencies, so you're not going to have as many to choose from, which is kind of nice. So we have J, M, K. So they started with the small one, J, M, K. is similar to triangle, we have to start with J, and N is going to be the same as S, and K is the same as Q, JSQ. So that order did matter. And my scale factor, they almost always will ask you on the test, what is the scale factor? The scale factor will be the same. It doesn't matter which side you choose. So you can choose 4 to 16 or 5 to 20, or if we had the other side, we could say bottom to bottom. But if you simplify 4 over 16, well, 4, you can use your calculator. 4 divided by 16, math, enter. 4 goes into 4 once, and 4 goes into 16 4 times. My scale factor is 1 to 4. And you might write it as a fraction also. The following problems can be solved using similar triangle. Outside, you notice that the sun is casting both your shadow and a light pole shadow on the ground. Then the angle between the end of your shadow and top of your head is the same as the angle between the end of the light pole shadow and the top of the light pole. Based on the diagram, what is the height of the light pole? So they kind of set it up for us. It's really nice. They gave us a picture, better than usual. And we're going to look at this. We're going to set up our proportion and see if they're the same. So they're telling us that the angles are the same. So it looks like this angle is the same as this angle, because it says the angle between the end of your shadow and the top of your head is the same as the angle between the end of the light pole shadow and the top of the light pole. So they actually might mean this one, this angle. Okay, so let's look at our proportions. So we know our side lengths have to be equal. And we're going to try to find out how tall this light pole is. So we're gonna do height over height. So x over 5.5. And I started with the light pole. I have to have light pole on top always. So then I have to keep the light pole on top. So I'm going to have equals 24 divided by 10, which is going to be shadow over shadow. Okay? And remember, what we do is we cross multiply. Whenever we have two fractions on both sides of that equality sign, we're going to cross multiply. X times 10 is 10x. 5.5 times 24 is 132. And if you divide by 10 on each side, remember whatever's multiplied by your x, we're going to divide by that number. Then our x is equal to 13.2. And we need our units. Our unit in this case is feet. 13.2 feet. There's other ways you could have set this up, but this is the way I chose. So if you think that there's a better way and you guys get the same answer, I think that's okay. To measure the width of a river, you use a surveying technique as shown in the diagram. Use the given lengths to find R to Q. R to Q. So we need this right here. R to Q. This is our X, right? So what I would do is set up a proportion first. It looks like these are my congruent angles. These are congruent angles. So I'm going to put height, R to Q is X, big triangle, over height of this one. So we're talking about the same side, right? In between the 90-degree angle and the congruent angle, in between the 90-degree angle and the congruent angle is 12. And then we have like base of this one is 63. And then the base of this one is 9. We're just going to do the same thing. You guys are going to have to help me out on this one. We're going to cross multiply. So x times 9 is 9x. And then 12 times 63 is something like 756. If I'm wrong, then correct me, please. Divide by the 9. And x is equal to 84, whatever the units are. We'll say units. And if we do not have units, if they don't give us one, put units. Please put them. It matters. All right, let's look at our first proof when it comes to similar triangles. Given, remember we always start with the given. PQ is equal to 6, PQ is equal to 6, PR is equal to 8, and a lot of you didn't even get this part right on your chapter test, but I hope you did. Most of you did. And this is all given. My reason is given. They literally give you this stuff. Now, I need these triangles to be separated. So this triangle, little tiny triangle, is QTP, right? And QT, right? P, and then R, and then S, and P. So we know P is the same in both, right? They're both sharing angle P. Just something that we need to know. So P to Q, let me plug in this stuff. P to Q is 6, and P to R is 8. P to T is 3, and P to S is 4. It says P to Q over P to R is equal to what? Oh, I guess we're going to plug in the numbers, right? P to Q is equal to 6 over P to R is equal to 8. And we can simplify that. You can use your calculator, plug it in, then press enter, and then math, enter, enter, and that should give you 3/4. P to T is 3, and P to S is 4. Good. So 3/4 is equal to 3/4, and this is the definition of proportion. That's what we set up a proportion. All right, now it's asking us for P to R. P to R. What goes over P to R? This is this side right here, P to R. Well, that same side is P to Q. So if we're going to start with the left-hand triangle, we're going to say P to Q over P to R. I'll make them red. P to Q is 6 over P to R is 8 is equal to P to T, which I'm making the same color, P to T over P to S, right? So this is P to T. And we can say this is the transitive property. So we said P to Q over P to R is 3/4, and P to T over P to S is 3/4. Well, if they both equal the same thing, we can say P to Q is equal over P to R is equal to P to T over P to S, right? They're both equal the same thing. So we can say this is the transitive property. Okay. Now, what other thing do we know they have in common? We've proven right now that we have our sides are proportionate. We also need an angle, or we need all three sides, but we don't have anything on Q to T and R to S. We don't have anything. We don't have a number. We don't have anything. So we can't prove that they're congruent. But like I said in the beginning, we do know that angle P is the same in both triangles, right? So I'll just make it black. P and P. So I'm going to write that in. I'm going to say angle P is congruent to angle P. And remember, if something is congruent to itself, that is always the reflexive property. And this is just like a reflection, right? Angle 5, or number 5, says my triangle, what am I trying to prove? Right here. Triangle PQT is similar to triangle PRS. Why do I know my triangles are similar? We only have two things so far. We have a side similarity and side angle side similarity. We do not have all three sides, like I said, right? We only have two sides, but we have the angle in between it now. So I know that that is because of side angle side similarity. All right, guys, I hope you had a good time, and I will see you in class.